The information depicted in this podcast is purely for informational purposes only. Please consult your healthcare professional before making any changes to your lifestyle or routine. Hey everyone, and welcome to the Boost Your Biology podcast. My name is Lucas, and I'm the founder of Ergogenic Health. Together in this podcast series, we will go underground to explore cutting-edge health and human performance insights that you simply cannot search on Google to help you upgrade your existence. So, without any further ado, let's jump into today's episode. Well, welcome everyone to yet another episode of the Boost Your Biology podcast. Today I'm joined in with a very, very influential figure in the peptides and wellness space. I've been looking at his work for quite some time, been listening to him on other podcasts, and I've learned quite a lot through Ryan. So welcome to the show, Ryan.
Yeah, thanks so much for having me. Good to be on, and good to be back in the Australian market as well.
Awesome, man. So maybe for my listeners, do you want to give them a bit of a background into, I guess, how you got into the anti-aging wellness space?
Yeah, so I sort of stumbled into it, as I think a lot of people do. I was a biochemistry undergrad, went to medical school at the University of Kentucky, and got to the clinical portion of the medical school and just absolutely hated it. I was seeing patients who were a little bit not doing well, and sort of just pushing them from one hospital visit to the next. Got a little bit depressing, and so decided to try and make some change, and did that by creating a pharmacy called Tailor Made Compounding. And when we started, I was sort of, I would say, mentored by a lot of markets like the Australian market. And we really wanted to offer a lot of these peptides to this US-based physicians. And we were actually very, very successful in doing that. And so we brought a lot of the peptides to market that are really frequently used now. Things like the thymosins, BPC, the growth hormone secretagogues, mitochondrial peptides. We were always into sort of innovation and development, and did a lot of that. And so was lucky enough to really build out clinical use here in the United States. And we're pretty successful in doing it. We sort of, as most people who are interested in these peptides often know, they do so much and are really so specific with a very good side effect profile. And we just hit a niche in the market. We grew to be the fourth fastest growing company in healthcare in the United States, and really just grew a lot of expertise in this area of peptides, in the area of longevity and really performance medicine.
So Ryan, do you want to maybe explore a little bit on, I guess, some of the real trending sort of categories or areas that you think peptides really can shine?
Yeah, and there's probably a lot of different areas we can talk about. If you're looking at traditional big pharma, the biggest areas of development in the peptides are the same areas you see most investment, with cardiovascular products, things to help with metabolic disease like diabetes, and then cancer. Those are probably the three leading areas of development. In this more preventative medicine community, where we're trying to stave off a lot of those chronic diseases like cardiovascular disease, diabetes, and cancer, I would say we see more things like mitochondrial peptides to enhance metabolic rate and to help with that deterioration over age. Along with that conversation generally goes into longevity, which it goes to not only the mitochondrial peptides, but the growth hormone secretagogues. How do you handle immune function? That's a big one, obviously, now in the global pandemic. And then it would be a little bit. I'd be remiss if I didn't mention that a lot of these peptides gained a lot of notoriety in this performance and athletic performance space, in things like body composition and athletic activity. And so doing things like that, as well as repair and recovery, and combining all of those things together into packages and programs, and using them with things like biologics and stem cells. And so the peptides are taking advantage of that classic central dogma of biochemistry, where they can really affect every process. And so they're really, the potential there is limitless, but those are some of the biggest areas.
Awesome, man. Yeah, I heard you briefly mentioned the BPC 157. I personally have had some remarkable experiences with that in terms of improving my gut health and just general, even an injury. I literally healed my torn meniscus in 2 weeks, and that was through oral form, which was phenomenal.
Absolutely.
Yeah. So
yeah.
maybe, yeah.
Well, sorry. I just want to hop on there. I'm going to be a huge fan of BPC as well. So much so that we actually bought the patent rights here in the United States, and so we are now sort of the producers of the BPC Arginate, or that orally stable version, which is so good for a variety of things. And I have similar experience with repair and recovery as well. I'm a huge fan of that one.
Yeah, of course. So Ryan, I really wanted to delve into some of the novel, I guess, mitochondrial enhancing peptides.
Yeah.
So do you want to start out by, maybe listing out or describing the first one, MOTS-C?
Yeah. So the MOTS-C is one that I was really, really excited for. And again, like a lot of these peptides, was sort of born out of this performance medicine. It is a product which is naturally produced in our body, and actually is sort of transcribed in this mitochondrial genome. As most people who have done any type of 23andMe or any genetic analysis, they often know that you have this mitochondrial DNA lineage. So your DNA is passed on from your mother in the mitochondria. And in some of those DNA, under metabolic stress, can be transcribed into the somatic nucleus. And so this is what happens with MOTS-C. It's really in states of metabolic stress. It's upregulated so that you can activate your mitochondria to undergo mitochondrial biogenesis. And it does this by activating AMP kinase and eventually, which leads to more mitochondrial biogenesis. And so as a result, it can help with performance and particularly endurance performance activities. It can help reduce insulin resistance, which is generally why the body performs it. And then as a third big category, it also is highly linked to longevity. There are a couple of Japanese centurion populations which have polymorphisms, which causes them to express this a little bit more often, and they're associated with longer lifespans. And so those are, I would say, some of the three big areas, but it's a naturally occurring peptide. And by supplementing it, we can see that we get a lot of those same benefits.
So in terms of, I guess, maybe some routes of administration for MOTS-C, do you want to tell us a little bit more about that?
Sure. So the MOTS-C or the MOTS-C at this time is really only available via subcutaneous injection, and that's the same with a lot of these peptides. For those who might not be familiar, just because they don't have much oral bioavailability, they're rapidly broken down in the stomach and the digestive system, and the MOTS-C is no exception. And so traditionally that is, there are a lot of different dosing mechanisms for that, and depending on sort of what you're trying to go for, one of the things that I would say about it is it's one of those things that some people can feel some energy with, even just after a few injections. And for anyone who is wanting to sort of handle themselves metabolically, if they're metabolically at risk for things like diabetes or anything like that, it's a product you might want to consider. And then the other idea is that if you're an athlete, using this before activity or exercise can have some positive effects as well. Going back to the oral bioavailability side of things, there are a couple of companies out there who are making oral versions of this molecule, and it's not actually the same molecule, but it's the same mechanism, and using this molecule as inspiration. One of those is a US company called Cobar Pharmaceuticals, and they've made a product called CB4211. And this is a product which, again, has the same mechanism of action. How do you increase mitochondrial biogenesis, and what effects it might have in various disease states? And that one in particular is one I've been paying attention to for a long, long time. And they actually have just made some other developments which are getting this closer to some clinical use. And they're really studying it for things like non-fatty liver disease and other things of that nature. But really, really exciting molecule, which might be an even improvement on the original peptide.
Super cool, man. So maybe let's discuss a bit on bioavailability challenges for a lot of these peptides. I know obviously that's always going to be, majority of the time it's going to be an issue, but what are some of the other strategies that you've utilized to improve, or like liposomal, other forms, things like that? Yeah.
So liposomal, unfortunately, it isn't as good of a strategy because you're still getting degradation. You're not necessarily protecting the peptide. Even though you're facilitating its diffusion, you're not protecting it in the gastric system. And so the leading area of development it can be looked at through things like, insulin, oral available insulin, or some of these GLP-1s or the glucagon-like peptides, which are used for insulin mitigation. Some of the commercial brands, I don't know about, in other foreign markets, but in the United States, it's marketed things like Victoza or the Ozempic, or most people living in the United States will see those types of commercials. And semaglutide is one of the newest GLP-1s, which traditionally is injected once a week, has better sort of stability in the blood system, which they're making into orals. And the way that they do this is by looking at permeability enhancers, intestinal permeability enhancers. And they use a product called SNAC, SNAC, which helps facilitate that transport across the stomach or across the intestines. And those, I would say, are traditionally some of the best ways and probably the most promising strategies to make these things bioavailable. Another strategy, an interesting strategy for some products, is iontophoresis. A lot of people might not be familiar with that, but essentially it's using an electrical current to sort of draw a charged molecule like a peptide or a peptide solution into the capillary bloodstream across the skin. It's a little bit different than transdermal, which you're sort of trying to sort of use things like DMSO to drive that across the skin. But the iontophoresis is using that electrical gradient, and that's been shown to be effective for some peptides as well. One that and you're getting some new content here because I've never discussed this on a webinar, but some of the ones that have been studied for this are molecules called one in particular called KPV. And KPV is an interesting product. It's a tripeptide. Literally, that's the amino acid sequence. It's lysine, proline, valine. And it's found it's found as a fragment of alpha melanocyte stimulating hormone. Oh, yeah. And so people traditionally associate that with obviously tanning, right? But this has no tanning effect. What it does is just has the anti-inflammatory effect. And so it's used for things like psoriasis. It's used for things like ulcerative colitis and those GI things. And so, it's an interesting product. It's even used for wound healing. And that's one of the ones that's been studied with this iontophoresis mechanism, which is good to point out, but it also can be done as an enteric-coated capsule, which is delivered directly to the intestine. And I've never talked about KPV, but I think that the mechanism of iontophoresis is a good example for how you can deliver this systemically, just even using something that you apply to your skin.
Super fascinating, man. That's definitely one to keep a lookout for. I'm really excited to dive into that one. Do you want to go back to because we sort of segmented away from MOTS-C, but I want to talk a little bit about 5-amino 1-MQ, because I am after hearing your experience with that, man, I can't wait to try that.
Oh, I couldn't be a bigger fan. 5-amino 1-MQ, for those of you who don't know what it is, I'm a very, very big fan. As we get into the mitochondrial peptides, we also talk a lot about this whole NAD salvage pathway. NAD has been very, very popular lately as it relates to things like addiction or anti-aging in terms of activating sirtuins, which are these anti-aging proteins. And so all of these are important considerations. The interesting thing about the 5-amino 1-MQ is that it inhibits an enzyme which takes nicotinamide out of that NAD salvage pathway. And so one of the things that we know as we get older is that our NAD decreases, and that's not good for all of the things that it powers. And so how do we rejuvenate that system? And a lot of people are doing things like Inomine, or like nicotinamide mononucleotide or nicotinamide riboside. We've also seen people do classical NAD through things like transdermal iontophoresis or IVs or whatever you're sort of referencing. The problem, though, is that you got to do this every day. It's a whole process. What this does is it blocks this enzyme which prevents those things from going out of the NAD salvage pathway. And this enzyme, which does take nicotinamide to 1-methylnicotinamide and therefore out of that salvage pathway, is called NNMT. And the interesting thing about NNMT is that it increases as we age. And it increases particularly in two types of tissue. It increases in a lot of different tissue, but also in fat cells and in muscle cells. And so this is an exciting mechanism. Whenever it was tried out in mice, the results were absolutely phenomenal. They lost around 10% of their body weight in 11 days, with the majority of that being in white adipose tissue, that unhealthy fat. In addition to that, you saw a 70% reduction in lipogenesis. So you're not creating any more fat cells as well. And then in addition to all of that, a secondary study came out, which I think relates a lot to my personal experience, which was that it could help repair and recover muscle cells by activating muscle stem cells. And that was exciting too, because the mice who used this had, after recovery, had twice as much muscle cross-sectional fiber area than the mice who didn't use it. And beyond that, they had, as we get into this ergogenic benefit, right, is that they got a 70% increase in muscle contractile force. And I think that that's what I saw personally. My athletic performance was heightened to a level I had not seen before. I would like to know for this one, and a lot of these peptides, that they're in different stages of regulatory approval and clinical study. And so this one has not been officially studied in humans, but has some really promising data in mice studies and continues to be more promising. In particular, it's owned by a company called Ridgeline Therapeutics now in the US. And they've got some amazing data. And actually, they're even connecting it now to things like senescence and epigenetic aging, which is sort of this whole sweet spot of performance, longevity, metabolic recovery, and repair and recovery. And so it's a really, really exciting molecule, and one that I think a lot of people will hear a lot about in the coming years.
Yeah, I mean, when I heard your experience with the 5-amino and the fact that it upregulate or enhance that contractile capacity of, that is just a unique, that's one thing that stood out to me. Like, this can be applied to pretty much every single athlete, any sport really. Exactly.
And, even if it didn't have those contractile force benefits or the muscle repair and recovery benefits, it still has the NAD increase benefits to increase metabolic rate, to increase energy utilization. And then those anti-aging benefits as it relates to sirtuin activation and that NAD salvage pathway. One thing I would like to share just from some anecdotal conversations is that it looks like that benefit of 5-amino-1-MQ is additive when you do use things like Inomine or the nicotinamide riboside. And so if someone's out there who's using products like True Niagen or some of those other things, then it's maybe something else to consider, the 5-amino-1-MQ.
Fantastic. Yeah, no, I'm very, very much excited. And one thing I don't know if our listeners understood is that it's orally bioavailable, right?
Absolutely. I should have mentioned that. It's actually not a peptide. It's a small molecule, and one that is incredibly bioavailable. It's so bioavailable you could even do this as a skin cream and have it sort of permeate into the system. And so absolutely. And it has a lot of different effects on a lot of different tissues as well. And so the studies that we're talking about are obviously related to what they've studied in mice, but probably has implications beyond that, things like Parkinson's and even a lot of neurodegenerative diseases. And so a lot of things to consider with that one, but extremely, extremely exciting. And I have never, out of all the things I've tried, which is unfortunately a lot, never had a better experience.
And just to clarify, I think you said your vertical jump, you had a massive increase in your vertical jump. What happened there?
It's ridiculous. Yeah, it's actually so ridiculous that I almost don't like talking about it because people just don't believe it. But it's I have so many witnesses to say this is true. And I'll tell the story again just for your listeners. We have an intramural basketball team for our company, and we were playing. I took 2 weeks off. The only thing that changed in those 2 weeks was I began the 5-amino-1-MQ and got new shoes. And unless the shoes were way more had way more benefit than I anticipated, I gained I would say conservatively 6 or 7 inches on my vertical jump in 2 weeks. I wasn't able to dunk the ball 2 weeks prior, and I come back into the gym for the first time, and it was, I swear they lowered the rims. That was honestly that, and everyone on my team was equally as surprised as I was, because they've been playing with me obviously for weeks. And so if I didn't have so many people sort of see it and verify it themselves, I wouldn't believe it as well. And so it was an amazing response.
Yeah, awesome. So, Brian, let's sort of segment into, I guess, a bit on immune health, because I know that's definitely, trending right now in the world. And I know we're not going to be obviously talking about, the use of these to combat the virus, but let's talk a little bit about thymosin alpha 1.
Yeah, absolutely. And I've said thymosin alpha 1 is one of my favorite drugs favorite medications for a long, long time. I think that the thymosin alpha 1 is well studied in a variety of different conditions. It's not FDA approved, but it was got FDA orphan drug approval in 2006 for malignant melanoma. It has been a product which is really, really exciting, but it ran out of patent in 1977. And so, it's been one of those things that's the reason it had to receive orphan drug approval, is that there's been no incentive for someone to take it to market for any of these conditions, because there's no way they'd make money off of it. And so that's a shame, because what it can do to the immune system is really, really exciting. What it does is it increases sort of a lot of cytokines to improve the innate immune system and sort of the adaptive immune system, to increase T cell response, to increase natural killer cell response, to increase plasma B cell response, and it has a special direct effect on viral infected cells and tumor infected cells by allowing them to sort of upregulate the machinery that allows them to be bound by the immune system. And so you look at this, it's been studied in HIV, it's been studied in any type of virus you can really imagine, including influenza and including SARS-like viruses. And as it relates to COVID, it's actually had 3 published trials in COVID. One was an original study in China, which didn't have a ton of patients, but showed a 30% reduction in mortality. You have a study which was published looking at over 334 patients in hospital settings, showing that it reduced mortality and improved oxygen perfusion to the lungs. And it's been studied, been published in Nature as one of the most promising off-label pharmaceutical options for COVID-19. And obviously, Nature is one of the most prominent journals that there is. And so it has a lot of applicability in a lot of different viruses, in anti-aging and autoimmune. It's really a way just to regulate and reset that immune system to do a better job. And it even has studies in influenza vaccines by increasing vaccine efficacy by 35%. And so as you get into this idea of a worldwide vaccine for things like COVID-19, it's definitely on the back of my mind. Again, you can never make any claims to say that it is treating COVID, but it is look like the initial data is promising.
Interesting. So with the thymosin alpha 1, are there any other sort of synergistic compounds that you think that would work well alongside it?
Yeah, so I'm probably going to go in a direction you might not want to go, but one of the products that also tends to have an effect on the immune system is these growth hormone secretagogues. A lot of people, so the thymosin is named for the organ, the immune organ, the thymus, for which it was derived. It's produced in the thymus fraction 5. And so the thymus is your immune organ where a lot of these T cells differentiate. And one of the things that happens as we age is you undergo thymic involution, or what they call immunosenescence. So your immune system stops to work, right, as you get older. And that's why obviously people who get the flu and are elderly are much higher risk of dying. Same with COVID-19. And so the idea is, how do you maybe restore the thymus's potential to do its job? And one of the ways you can do that is by stimulating the thymus to undergo thymopoiesis. And you can do that because it has growth hormone receptors, it has IGF-1 receptors, and it even has growth hormone releasing hormone receptors, all of which can and have been studied to increase thymopoiesis. And growth hormone itself has been shown to increase the thymic fat-free fraction, which is sort of a measurement of how well this organ system is doing its job. And so usually with immune system sort of side by side, I always talk about thymosin alpha 1, the thymosin beta 4, and then growth hormone as well.
Yeah, cool. So obviously that one there. Now, in terms of the actual administration, can that be, do you want to talk more about that?
Yeah, so these are all relatively large peptides. The ones I mentioned, the thymosin beta 4, and a lot of the growth hormone secretagogues. And so, unfortunately, they're injectable. And so, the good news about the thymosin alpha 1 is that in most protocols, it's traditionally given as 2 injections a week. It's not one of those daily injections, which happens with a lot of the peptides due to their short half-life. And so usually it's given around 1.6 milligrams twice weekly. And the thymosin beta 4, it has a lot of varying dosing protocols, but almost always given subcutaneously, as is these growth hormone releasing hormones like the CJC, the Samorelin, the Tesamorelin, and the Ipamorelin.
Let's sort of delve into some of those growth hormone releasing peptides and things like that.
Sure.
Yeah, so obviously a lot of my listeners will probably be familiar with the MK677 as the original sort of ghrelin secretagogue or whatever. So do you want to talk a little bit about how they sort of differ?
Yeah, definitely. And so the first thing to know about these growth hormone secretagogues is that they're all working on the pituitary. So they're all encouraging growth hormone release in the pituitary. And usually in order to do that, they're working on one of two receptors. One is the classical growth hormone releasing hormone receptor. And that is usually hit by products like Samorelin, which is a 29 amino acid fragment of growth hormone releasing hormone, or CJC, which is a modified version of that original 29 amino acids. Actually, they call it the tetrasubstituted. So 4 amino acids are changed from Samorelin. And then you have the tesamorelin, which is the 44 amino acid sequence of growth hormone releasing hormone with a transhexanoic acid on the end to improve its stability. And so those are really the products which are hitting that growth hormone releasing hormone receptor. The interesting thing about that receptor is it's relatively you won't develop tachyphylaxis or resistance to that receptor, which is why you can go high and hard on those. The alternative is the ghrelin receptor. And so most people are familiar with ghrelin as the hunger hormone, but it also secretes growth hormone. And this is where you get a lot of other interesting products to work, including things like the MK677, also called ibutamorin. Then you get the GHRP2, the GHRP6, the hexarelin, and the ipamorelin. And so all of those hit that receptor. And that receptor is a little bit different because it can become dysregulated relatively easy, especially if you hit it too long and with too high of a dose. And so ideally what you'll have is you want to take one from one group and one from the other group and pair them together for optimal growth hormone secretion. And so usually that's been done with things like, the Samorelin and ipamorelin, or the Samorelin and GHRP2, or the CJC and ipamorelin or GHRPs, so that's sort of, I would say, the how the mechanisms by which they work. The MK677 is interesting because it's the only non-peptide on that list. It's actually a small molecule, which means that it's orally bioavailable. It's actually fairly potent with 50% increases in IGF-1, which is usually the surrogate marker for how we measure that growth hormone increase, because IGF-1 is going to be increased by growth hormone stimulation. And so the thing about MK677, which it makes it popular, is the oral bioavailability and the high increase in IGF-1. However, it has some drawbacks which are not always good. In particular, in most of the long-term studies, they show that you actually don't decrease weight, which is a lot of the reason that a lot of people are doing this is for the body comp effects. You actually increase lean muscle mass, but you don't increase weight. And in some studies, it shows that increase in lean muscle mass doesn't actually translate to strength benefits, even though you're seeing increase in lean muscle mass. And so for a lot of reasons that a lot of people tend to avoid MK677, mostly because like ghrelin, it increases hunger. And that's generally the reason it probably increases lean muscle mass, if it doesn't really decrease that fat mass.
Yeah. So maybe we know that part of the mechanism of that MK677 is to ramp up that IGF-1 production, but are there any other sort of strategies or ways that we can ramp that up or support that pathway?
So, IGF-1 generally is a hard thing to predict. It's even hard to predict because labs aren't that consistent, even measuring IGF-1. And so even if you did nothing, you might see IGF-1 jumps of 50 points from one draw to the next. And so knowing exactly what changes this can be a little bit difficult sometimes, but even lifestyle factors like sleep and dietary interventions, all of those things affect IGF-1. And so from a pharmaceutical perspective, there really is no other pathway to increase IGF-1 other than this growth hormone pathway. But there's a lot of things you can do in a lifestyle perspective to also increase that. And whenever we're talking about things like CJC and ipamorelin, which might not have the same increases as things like tesamorelin and MK677, you might oftentimes be better implementing lifestyle change than others. And as these peptides have become a little bit more restrictive in the United States, so we've also been going to things like amino acid formulations, things like arginine and glycine can increase growth hormone secretion. Even things like creatine can increase growth hormone secretion. And so those are some ways you can also just dietarily change that metric.
Yeah, cool. Awesome. So I want to sort of touch on a bit about Metformin. I know that Jay Campbell's a huge fan, and I personally experimented with it and had some benefits in terms of body composition, things like that. But I'd be curious to know, like, what you think may compete with Metformin.
I think that's a difficult question because a lot of people use Metformin for the insulin sensitivity effects, right? And other people use it for its mitochondrial effects. And they each sort of a different thought process behind each one. And actually, I know that you and I will probably have a later conversation about one of my new companies, True Diagnostic, which is doing epigenetic testing. But actually on Monday, they published a paper which predicts how you're going to respond to Metformin via epigenetic measurements. And so hopefully we'll know a little bit more about who it works in and why in a little bit. But generally the alternatives to Metformin tend to be berberine, right? Things that increase AMP kinase. And berberine's a really good example. There's also a really exciting new product called dihydroberberine, which isn't really available, but still exciting for its effect on that AMP kinase and the insulin mitigation strategy. The good things about the berberines is they don't have the same GI side effects that metformin has, which is the number one reason people traditionally don't stick with metformin. So it just depends on why you're using it. I still tend to be hopeful about metformin because it's obviously the standard of medical care as a sort of the step one to control insulin resistance. It's extremely inexpensive, and that's obviously a great draw. And then it is gathering, I would say, a lot of political pressure to be the first drug investigated for anti-aging, which is great because if anti-aging and aging can be classified as a disease, I think you'll see a lot more focus being poured into interventions like we're talking about today.
Of course, yeah. Mm-hmm. And there's a few debates around whether or not metformin lowers testosterone as well. So
definitely, and I think that definitively people can say it's probably not the best for those athletic performance effects. And so for those people who are worried about maybe some of that negative effects, just like rapamycin, they might be better going off to some of the more natural products like berberine.
It's interesting how you mentioned the dihydroberberine, because I did an interview with Sean Wells a couple of weeks back. We spoke very extensively on that DHB, which is, I definitely think that's an up and coming superstar in the anti-diabetic space as well.
Absolutely, good to know that obviously that conversation is happening. I haven't been able to find, I would say, a really great supply here in the United States, but I'm hoping that someone will turn that corner here relatively soon.
Yeah. All right. So what about I know there's you've probably got a few weapons up your sleeve in terms of optimizing sleep. So let's talk about some of the compounds that may be able to help with sleep or deep sleep.
Yes. Yeah. Sleep's hard. And it's one thing that I suffer with that I've, had some thorough investigations on, everything from, pharmaceuticals to non-pharmaceuticals like, electromagnetic frequency devices. And so I say all of this to say that I also track a lot of my sleep with an Oura ring, and have not, as much as I've tried, been able to move that deep sleep metric very much. And so I can tell you a lot of things that haven't worked for me, even the EMF devices, in the peptide world, there's a product called obviously deep sleep inducing peptide. It's been around since the 1940s, isolated originally from rabbits. And although I've used that product, I did notice a sleep benefit. One thing that might be interesting to a lot of your listeners is that I did receive some benefit, just not in sleep. I received a big LH bump. My luteinizing hormone bumped up by a couple points, and my testosterone levels increased as well. And so, again, not like its namesake. It's not as great for sleep as its namesake, but it did have some type of effect that was, I definitely thought positive. And then, I think that out of all the things that I've seen, I'm a big fan of low dose, low dosing of things like melatonin, 300 micrograms a night to really establish that, not the huge doses you often see. And there's a good MIT study which talks about why that is. And then there's also, I would say, a Cordalis extract called THP, which, it's gotten a bad marketing name. It had some negative effects, but it's tremendous at actually moving that metric for me. And a lot of other things aren't.
It's interesting that you brought up the LTHP, because I got that listed on my site as one of the sleep categories, because it's definitely unique in the fact that it sort of blocks that dopamine receptor and shuts off the excitatory stimulus that we're buzzing off all the time. So
exactly, and it's one thing. Like I said, I've tried just about everything you can imagine. Really, the only two things that move that needle for me are actually Benadryl, and then Benadryl, and then the THP. So good to know that you're familiar with that as well.
Yeah, of course. All right. So what about I want to sort of go back to some of the muscle growth activation pathways, and in particular, sort of activating muscle stem cells. So is there anything that you've explored in that realm?
Yeah. So the first one is one we've already talked about. I think that obviously the 5-amino-1-MQ is great at that in a way that is unique. Generally, the second product that's usually talked about there is mechanical growth factor, or MGF. It's actually a splice variant of IGF-1. So similar in that regard, but it can activate those muscle stem cells to create hyperplasia instead of just that hypertrophy, right? So we're usually used to resistance training, increasing the diameter of those muscles, but the satellite stem cells can actually increase the muscle cells themselves. And so a lot of people have liked the MGF theoretically. I would say that in my experience, the MGF is expensive. It's hard to dose systemically. It looks like it needs to be produced locally to have a lot of different effect. And generally, I would say that I haven't had the best results with that one. And so I'm not although that mechanism of action is thoroughly described in the literature, it looks like it might have to happen more endogenously through some of that stretch resistance loading. And so that might be one day it's something for viral vector delivery with things like gene therapy, as they might do with follistatin, right? The follistatin is another one that's gained a lot of popularity because it's able to inhibit myostatin and inhibit that breakdown of muscle. So obviously everyone's seen those myostatin bulls or animals, which are just, balls of muscle really. But that one's something to think about. As we get into other products I like that are similar to that follistatin that I've seen good results with, I like a polyphenol called epicatechin. It has, I think, in 7 days, an 11% increase in hand muscle strength in some studies at around 500 milligrams a day. And so that's one that I've experienced a lot of benefit with. And then outside of that, you start getting into things like the SARMs and anything that's working on those androgen receptors. And so those are obviously a little bit more of a commitment, especially with those androgen type things. But some things that might be less of a commitment in that regard to disrupting the HPT axis are things that increase the LH and FSH. So things like the DSIP, as I mentioned, things like the kispeptin 10, things like HCG, HMG, or even gonadorelin. So all of those, I would say, are maybe some ways that if you're trying to get some androgenic stimulation without committing to things like exogenous androgens, you might want to consider some of those, as they can really increase your levels of LH production and your testosterone production.
Yeah, on the topic of optimizing that HPT pathway, do you want to briefly talk about the differences between clomiphene and N-clomiphene?
Yeah, definitely. So the clomiphene is something that's been popular for a long, long time, right? As a way to block estrogen receptors, so that it sort of tricks your body into thinking it has no testosterone, because testosterone is converted to estrogen via aromatase, and the body senses that. And if you can block the sensing of this sort of estrogen pathway, you can encourage the body to say, hey, we need more testosterone because we need more estrogen. And so that's sort of the thought process behind it. The clomiphene actually has two isomers. One of those is the N-clomiphene, which has a lot less side effects than the regular clomiphene, and looks to be a little bit more specific. And so generally when comparing the two, they're relatively similar. They're both orally bioavailable. They both are going to be blocking that estrogen receptor. It just looks like the N-clomiphene is usually a lot more well tolerated. And so you can use it even at less frequent intervals. People can usually do 25 milligrams every other day. Some people even do 50 milligrams every 3 days, or you can do a small dose every day. I think that there are a lot of different dosing strategies for that, but the enclomiphene tends to be, I would say, the more preferred mechanism than the clomiphene, just because it has less side effects. You don't have to worry about really nearly as much as you would with the clomiphene.
Awesome. Yeah. So Ryan, let's sort of segment into, obviously you mentioned briefly before about how we can figure out whether metformin is applicable to certain people and like basing that on their genetics. So let's talk about True Diagnostic.
Yeah, absolutely. This is my baby, my new baby, I should say. And I actually got into it because of the peptides. And so, these peptides I saw definitively every day with our pharmacy changing patients' lives. I saw impact for the better. And the most frustrating part about that is that it was hard to prove outside of an anecdotal scale, because a lot of these products, as I mentioned with the thymus alpha-1, have no incentive for companies to develop and to sort of share their good results with the world. It's just, individual patients are motivated, but without FDA approval, it's hard to scale that out. And so one of my thought processes has always been, how do we vet this? And so I was familiarized with the idea of epigenetic age over the past couple of years. Really, in 2013, they created these age clocks, which are able to look at not the genetics of your DNA, but the epigenetics of your DNA. So the changes which happen to your DNA to affect expression. And the best way to describe that, I think, is generally, all of the cells in your body have the same DNA. But what makes the cells of your skin any different from the cells of your heart? And the idea is that it's what is epigenetically programmed to be expressed. And so what proteins are being made in some cells versus other cells. And their body has a way of manipulating these changes called epigenetics. One of the big epigenetic changes is methylation. And by looking at methylation, they were able to essentially find ways to predict the age of an individual. This was used in 2013 by Dr. Horvath and Dr. Hannum, originally for things like dating refugees to see if refugees are adults or minors, and therefore applicable for asylum, or to look at DNA left on a crime scene to see how old the person might be if they're a suspect for a crime. And more recently, through some more innovations in this type of testing, it's been even able to predict death, really, really accurately. So to basically say, hey, you're going to die at this date, and see what that means. And so all of those things I think are interesting, but were never super applicable to me. That changed about a year ago when they came out with a trial to show that they could reverse your epigenetic aging rate with 3 simple products: metformin, growth hormone, and DHEA, things that are very, very common. They actually, in 1.5 years, they were able to reverse the epigenetic aging rate of these individuals by 2.5 years. So just to give some context to that, if you were to reverse the epigenetic aging rate in the entire world by 7 years, you would cut disease in half. 50% of people would no longer be sick, which is an amazing statistic. And so all of a sudden, I saw that study published, and I thought, imagine what we could do by investigating all of these products we're currently doing. What if we add some metrics to them? And because now this is an objective metric, it's not one that is clinical, right? You don't have to gauge symptoms and give a score. It is an objective metric. And it's an objective metric that now is ultimately tied to longevity, right? In terms of how long you can live. But not only that, it's also tied to health span. So how healthy you are, right? No one wants to live a long time being sick, right? So it's also now health span and lifespan. And so that got me really, really excited. And it brings up this idea of epigenetic testing and how we can use it for a variety of things. And this field is one of the fields that is just absolutely exploding. There are new published trials on this every day. As I mentioned, even on Monday, there was a trial published that said, you could gauge how metformin is going to work in people, both from an insulin perspective, a blood sugar perspective, as well as a side effect perspective. And that's just one of the many, many applications. You can now use this to look at telomere length, to look at how many times your cells have undergone mitotic division. You can look at it to the rate of aging to predict cancer or cardiovascular disease. All of these things are sort of popping up in this type of diagnostic platform. And the really cool thing about this is that it's super, super precise and specific. And so you get to know really, really exciting health outcomes. And for anyone who's interested in this optimization in their own health, this is the one metric which is correlated to the most correlated to all chronic disease. So if you're interested in your own health, this is something you should know.
Awesome. So, Ryan, do you want to tell us a little bit more about the progression in terms of like when that is the company live and active now, or like how can people learn more about it?
Yeah, definitely. So our company's name is True Diagnostics, TRU Diagnostic. And if you look that up, you can see a little bit about what we offer. What we offer now is sort of an analysis of your methylation profile. And the good thing about this, which is different than genetics, is that it's changeable. It is within your control. And so let's just say that, you're 55 years old and you get a biological age of 60. Right? That's not a good thing. You're aging faster. Your body's aging faster than you are chronologically. And that's not a good thing. So for every, for instance, 3-year increase in epigenetic age, you have a 16% increased risk of developing cancer in the next 3 years, or a 7% risk of dying of cancer in the next 3 years. And so those are just some of the metrics you can sort of draw from that. But it's even more than that. It's actually got a diabetes risk predictor, which is more predictive than the standard of care of medicine, which is fasting insulin and HbA1c levels. So you can detect risk of diabetes earlier and make the necessary interventions. So 60% of your epigenetic profile is changeable. 40% is inherited from even your great-grandparents. Wow. But the good news is your DNA is not your destiny, right? You can actually change those things if you know fast enough. And the idea is we want to get you the information so you know in time to make those changes.
It sounds amazing. I mean, it's definitely you're definitely pioneering something new there, and it's just really going to improve the therapeutic outcome of these compounds that we just spoke about. It's going to help us structure out exactly what stacks to make for people, and
exactly, and on a personalized medicine basis too, because how you react to metformin might be a lot different than how I do, or thymosin alpha 1 might be different. But now we don't have to just use the standard of care of medicine. We can say, hey, now this is objectively how it affects me versus how it objectively affects you. And we don't have to wait 40 years with a placebo control group to judge how it's affecting our own longevity or our own health span. We can see it in real time, even as little as 8 weeks. And I think that's why I'm so excited, because, all of these things that I'm doing, I can now get feedback on, other than just how I feel. I can get some objective, hard to argue with evidence.
Yeah, cool. No, it's definitely one to keep lookout for. We might have to dedicate another whole episode to that and to talk about that once it's progressed and you got more users and things like that. But I'll definitely be linking that in the description for my listeners. Definitely, we'll find a way to partner up and help promote that, which would be really fun. But Ryan, I want to sort of wrap it up there and just sort of say a massive thanks for coming on the show, man. It's been an absolute pleasure having you here. What I might do is actually in the future put together another list of sort of peptides, compounds, things like that, novel research chemicals that we can discuss.
Absolutely.
And, I'll get my audience involved and things like that, and just be awesome. So, Ryan, where can people learn more about you and your services apart from the True Diagnostic?
Right now, I hate to say it, in the United States, we used to offer a lot of these things as Tailor Made Compounding pharmacy here in the U.S. Unfortunately, we're not able to do that much anymore. And so really, if someone wants to reach out to me, they can always reach out to me at ryan@truediagnostic.com. I'd be happy to talk about any of the peptides, even if it has nothing to do with epigenetic testing, because I really do believe in these molecules. I think a lot like you, and would love to share what I know and my experience. And so if anyone wants to reach out, they're more than welcome to reach me there. And hopefully we can hop on another call. I think that, I've 7 or 8 peptides I still want to do and still interested in doing that we never got a chance to roll in the pharmacy or never got a chance to talk about. So hopefully we'll be in contact over the next couple of weeks and continue to share that information.
We definitely will, man. And just want to say massive thanks. It's been a pleasure having you on the show.
Yeah, thanks for having me.
Thank you everyone for joining in to today's episode. For in-depth show notes and lessons learned, visit nofilter.media/boostyourbiology.
This has been a No Filter Media production.
Say what you want.